morning, everyone. My name is Fernando, and as Director of the Caribbean Center for Rising Seas, a program of the Puerto Rico Science Trust, I'm thrilled and it's a pleasure for me to be hosting this session with Alejandro Mieses of Terra Firma. At the Caribbean Center for Rising Seas, we are very interested in investigating and designing pathways to help Puerto Rico adapt and thrive despite the challenges of the 21st century regarding sea level rise, storms, tides, and other kinds of threats and extreme events. As you will see, we have great curiosity to better understand Terra Firma's work in this field, where remotely gathered space data informs decision makers on the ground. So for those of us that are just joining us, my name is Fernando Pavon, and I'm hosting this session. It's my pleasure to introduce Alejandro Mieses. Alejandro, please tell us a little bit about yourself and the work you do at Terra Firma.
Of course, first and foremost, thank you so much for having me. It's truly a pleasure to be able to be part of this event, to speak among friends, and to be able to discuss these ideas or our work more in depth. Can you hear me okay? Yeah? Sounds great. I'm Alejandro Mieses. I'm trained as an architect and urbanist, and for the last 12 years or so, I've dedicated myself to software development, specifically as the CEO of Terra Firma. What we do, we use satellite data to forecast environmental risk, specifically in Puerto Rico, at a square meter position that includes erosion, landslides, flooding, wind-related risk, and solar energy potential currently in Puerto Rico, as I mentioned. What you're seeing are sort of the visuals of the work we develop throughout the island, sort of forecasting and visualizing these environmental events which we may not be conscious of. The work we do stems from a very fundamental question. When we forecast environmental events, we see it from the atmospheric level. We see that as hurricanes, as we're accustomed to, as these spaghetti diagrams, as the footprint of these events from satellite imagery. But the way we experience them is through the ground, through flooding, through erosion, through things that actually affect us at a human level, at a human scale, which is much lesser or of higher resolution than what we experience, of course, as humans. And in that case, we are dedicated to forecasting events on the ground, catastrophic events on the ground, not at the atmospheric level.
Thank you. Now, how is it that you use satellite data and data science to forecast these flooding events and other hazards?
Yeah, so we combine a series of different satellite imagery coming from NASA. We have the entire topography of Puerto Rico coming from NASA and USGS. We have all of the soil physics properties coming from USDA. How fast does the water move through the ground superficially and in depth throughout the ground? What's the factor of erosion? So we have a pretty deep understanding of how these things move at a physics level. We have the meteorological data of NOAA since 1941, extrapolated by the hour, and we as well combine a series of commercial satellites from Google, from Microsoft, from ESRI, that allows us to forecast these events in 15 different products. That includes solar accumulations throughout the year. It includes as well cumulative hurricane winds from any hurricane, specifically Hurricane Maria, which was in modern times the largest hurricane we've experienced. And it as well, as you'll see, combines a series of other flooding events throughout our history.
Fascinating, fascinating. Now, how does all of this data, these observations, and this work translates to your observations of the Caribbean, the tropics, Puerto Rico?
Sure. We share many climate similarities throughout the Caribbean basin. That includes Florida, that includes the Dominican Republic. The recent weather events we've encountered in November, in October, in February of this year are shared with the Dominican Republic. If you've seen the news, November 6th, and I think the 8 inches of rain that fell in Puerto Rico, the 21 inches of rain that fell in the Dominican Republic, all of these things can be modeled and are actually sort of predictable in a way. So we actually model these things throughout, including sea level rise, and as you'll see, flooding events from what happened in November, so you'll see it soon enough. But it's important to understand these things because those are road infrastructure, roadway infrastructure, those are homes, those are properties that not only affect sort of the property or locale in itself, they affect sort of critical infrastructure as the airport, they affect the connection, in this case from the East Coast to the metropolitan area. Those are jobs, those are economic sort of setbacks that happen throughout, again, and will be happening throughout the near future in Puerto Rico. So what you're seeing is the sea level rise up to 1.5 meters in San Juan, the Luis Muñoz Marin Airport. And as well, what you're seeing here is actually those events up to 9 inches of rain in throughout the entire area. And you can see how the Valderia de Castro, the PR26 is affected. I'm sorry if I wasn't speaking to the microphone. But you can see exactly what happened. And you can sort of understand that at a physics level, and not only to understand that at an experiential after it happens, after the fact, but be able to prepare for these events, and not only to understand, okay, yes, the major artery was obstructed in 3 main points, but also it affected Ocean Park, it affected Villa Palmeras, it affected other areas throughout that event, and what will happen in the future as, again, sea level rises, the properties that will be affected, at what rate will they be affected, is quite critical for not only governments, for insurance, it's critical for construction, for the reconstruction of Puerto Rico, and any other country that will happen in the future. That includes the Dominican Republic, that includes Florida, that includes Texas, of course, Louisiana, and any other country, specifically in the Caribbean, or state in the Caribbean.
Amazing. So that is how you form risk modeling. It's just terrific. Now, who are you seeking then to empower with these tools?
Yeah, we're seeking to empower decision makers across scale, not only governments, not only insurance companies, which are, of course, are large. They encompass a large or widespread damage, but also local communities, any landowner. We believe that empowering people with the tools to solicit funding, to understand the environmental damage, or to understand the environment they are living in, allows them to be able to better coordinate amongst themselves, to be able to establish relations with critical nonprofits, as maybe the Puerto Rico Science Trust and the Center for Caribbean for Rising Seas, and as well seek funding from federal sources, be able to better coordinate these responses or the reconstruction of these areas, not only as independent projects that may happen through independent firms, but to be able to understand how they coalesce and build an environment together.
Really interesting. Now, what have you discovered in this process?
We've discovered that these events will be, of course, we know this, they'll be more frequent, they'll be of larger magnitude in the future. And at some point, the attrition cost of having to rebuild constantly and having to not only rebuild after a disaster, the disaster is sort of the pinnacle of it, but there's commonplace events or temporary events that happen throughout the year, whether that's erosion. We don't register the specific point at which erosion happens. They happen in geological time. They don't happen in human time. And it's the same thing with floods. It's the same thing with all of the natural cycles, except for hurricanes and earthquakes, which is the ones we understand because they happen in a single day, let's say, or throughout a series of days, so that's in human time. But understanding that the cost of operation of, let's say, the airport, of repairing roadways, at some point they will exceed our capacity, or they will overwhelm our capacity to repair them. So to be able to better understand disaster preparedness and be able to better understand measures for mitigation before disasters happen is the key to not only protecting our cities and natural landscapes, but also protecting the properties, lives, and economics, in this case of Puerto Rico.
Really interesting. I can see that you are tackling different scales, from the home to the infrastructure to the region, the hydrological basin, and so forth. Now, as we start approaching the end of this discussion, what would be some of the conclusions that you've reached during this process with your enterprise?
I think, like you mentioned, having a systemic approach to emergency management, to land management. Again, emergency management is a small part of the equation. It's the one that touches us most deeply. Again, a home is the economic backbone of any person in this country. It's most likely their largest investment, and it's commonplace throughout the island. So losing a home, in Puerto Rico we have backup like FEMA, and we have other insurance companies. The Dominican Republic is much more drastic to lose a home. You're losing your life savings. You're losing your sense of community. You're losing sort of your contacts as well. You have to move to another place. So understanding these things at a human level, as well as a systemic level, and being able to respond. We can't respond to these things as widespread as they happen. Right now, you can see there are thousands of homes. We can't respond to thousands of homes, but we can respond to the local conditions where this flooding may happen, where these events may happen, to prevent it. And it's much more economically viable to do that than to address it after the fact, after a disaster happens.
Now, I would guess that this is a critical time because there's a vast amount of money coming to Puerto Rico for disaster relief and so on. Do you have some other thoughts around that?
There's the economic or intellectual landscape that's happening right now, and this conference or this event is really critical in promoting sort of this sort of thinking, sort of the understanding of how space or satellite imagery can contribute to understanding our conditions on the ground, our conditions back in Earth. And that's becoming ever cheaper. There's an ever cheaper constellation of satellites which you can rent, which you can access the data from, which you can launch. So those costs, those economic barriers are coming down quite fast. The other one is the economic landscape we are well aware of in Puerto Rico. All of this reconstruction funds, mitigation funds are coming into the island. And all of the, whether it's grant funding from NOAA and acceder, from all the agencies we know, or whether it's reconstruction funding, that's a very big incentive in promoting sort of sort of these efforts. And the other one's the will of the common population, which are becoming ever sensible to these events, to understanding them, to being involved in them, to have agency. Not only be mere recipients of a disaster, but be able to better harness environmental cycles for the benefit of humanity and for the benefit of the environment as well.
Alejandro, you have an admirable, inquisitive spirit. I applaud that. Where do you see the next iteration of your platform, your software going?
Yeah, there's a lot of exciting things going on within Terra Firma. Thankfully, we have established partnerships with Google, which gives us access to their suite of sort of environmental repository, satellite data repository, and as well as the machine learning and software developers from them as well. We are part of the Google for Startups Climate Change program, which actually ends today for us. So that gives us a very large access, and as well, we have partnerships with AWS, which is doing sort of like commercial for Pepsi and commercial for Coca-Cola at the same time. But it's interesting because they as well are really keen on developing climate tech and developing or allowing us access to the software engineering team that can allow us to scale globally.
Thank you so much. Alejandro, it has been a pleasure speaking with you and hearing you tell us all these amazing things about what you're doing. Now, unfortunately, we've run out of time. We don't have time to answer questions right on the session, but Alejandro will be more than happy to speak with you outside in the hallway so we can give some room to the next group. Please, thank you.
Thank you so much.